So dear participants, let's get back with our discussions on data files. And today at the outset, we will start with the integer file. Remember that integer file is going to be very important so far your mathematical implications with PLCs are concerned. Now you can see that there are as many of 1000 integer elements in this PLC 5 family. The address lies from N7 is the designator of this integer family, and you can have this address from 000 to 999. That means you have got 1000 integer elements, and each integer elements is a single word element. Okay, single word means they are at 16-bit. So if we think of that particular figure of blocks, then you can find that parallelly they are at 16 bits that constitute one integer element. Remember that whatever values here, they are all of integer type. That means decimal point cannot be taken care of by the integer file. Okay, now you can see the address example we have given. The address N7100, it actually addresses the word 100 of the integer file. Bit addressing is decimal from 0 through 15. That means that bit addressing you can also do, that is allowed from 0 to 15 because it is a 16-bit element, so definitely bit addressing is allowed from 0 to 15. So the example is given like this: bit 12 in word 15 is addressed by N7015. That is, this is the word 15 address, and in which we are talking about bit 12. Okay, so this is the example that you need to consider. Next comes the floating point file. In the floating point file, actually we can very easily consider the decimal point. And remember that if the value is very small or it is very big, you can see also that it can also take care of uh, raised to the factor. Okay, so if you have got 2 to the power 8 or 9 to the power 15, whatever it is, that can be taken care of in case of this floating point file. Okay, the floating point file is a 32-bit element, right? Because this is, we can handle here a larger data or a very infinitesimally small data. Therefore this 32-bit element is required over there. There are almost 1000 elements. They can be addressed from 000 to 999, and the designator is F8. Okay, so here you can see integer was given by N7, and this floating point file, it is given as F8. Remember one thing which is very important in case of this floating point file, that individual words or bits cannot be addressed in the floating point file. Now individual words I am talking about because it is already, we have discussed that it is a two-word element. So you cannot take care of individual word here, and the bits also that cannot be I should say addressed in case of a floating point file. Okay. Uh, Now you see in this particular slide we will see that uh, which data file you should use according to the application. You can see here the bit file, integer file or floating point file can be used to store status or data. Okay, so these three files, this bit file, integer file or floating point file, can be used to store both status or data. Which of these to be used depends on the intended use of the data. That means your application will demand that which one should you use. You can see that if you are dealing with status rather than data, the bit file is preferable, because we have already seen that bit file is taking care of the internal relay operation. So therefore, what is the status of the internal relay? Because internal relays, they do say either high or low. Okay, so they are very least bothered with the data sector. So therefore, if we are dealing with status of certain inputs in an intermediate state of the program, then this bit file is always preferable. If we are using very large or very small numbers and that require a decimal point to have the data, then floating point is preferable. Now you should know one thing, that floating point data type, they have a restriction. Okay, because it may not interface well with external devices or internal instructions such as counters and timers, because it uses 16-bit words. In such a situation, you are always preferring the integer file type. That's why it is safe to use an integer file type for most of the applications. But if your condition does not allow you to use an integer, or it requires a decimal point invariably. It requires something which is very big, some data which is very big, that you should express in the terms of this uh, raised to the power factors, then definitely your floating point data has to be used. So you can see here, this is the particular screenshot of RS Logix 500 software platform, but you can see these are the different data files. Okay, you can see the output, input, status, binary, timer, counter, control, integer, float. So everything is there. You can see over there, integer is given as n7, float is given as f8. So when your program has been performed, then what is the status of each and every register, that you can check over here also. So this facility is there in almost every manufacturer's software platform. So this is how the things actually look out in the data file section and program file section. And now we will be considering directly on the syllabus part that talks about the mathematical expressions of that are possible with SLC 500 family of PLCs, which are very typical type. I will be talking in very typical manner, and if you need to go for any particular PLC which is apart from SLC 500, then be sure to uh, get whatever you are getting taught here compared with the things over there, and then you go for programming those PLCs. Thank you.